Welcome students, in this class we are going to see how to integrate this. Now I will be utilizing trigonometric substitution. Now this is a very important result. It will be used in solving huge questions, specifically that are appearing in competitive examinations. So foremost I will start off by taking x is equal to sine theta. If you were to differentiate this, you get dx differential of sine theta is cos theta d theta. So this is rewritten as, in place of dx you substitute cos theta d theta divided by root of 1 negative. In place of x you substitute sine square theta. Now we got a formula, 1 negative sine square theta is cos square theta, so you substitute that. So this is equal to cos theta times d theta divided by root of cos square theta, which is equal to cos theta d theta. Root of cos square theta is cos theta. So cos gets cancelled, giving you d theta. Now you need to integrate d theta, which will give you theta. But you will have to revert the quantity back in terms of x. Now let me work that out. X is equal to sine theta. Therefore theta is going to be sine inverse of x. So this is going to be sine inverse of x. Plus, since we are dealing with indefinite integral, we need to place c. Now this sine inverse is also written as arc sine x plus c. So have that in mind, and we have a very important result. So what is the important result? Integral dx divided by root of 1 negative x squared is sine inverse of x, positive arbitrary constant c. So that is the end of this particular lesson. We will move on to the next video.